On November 8th, 2025, astronomers pointed their telescopes towards something that shouldn't exist. What they saw made them question everything. A mile-wide object from beyond our solar system was shooting jets of material 3 million kilometers into space, 7 times the distance from Earth to the Moon. Jets pointing toward the Sunday. Jets pointing away from the Sunday, both at the same time. According to current models, this object is losing 50 billion tons of mass every month. But here's the problem. The entire object only weighs 33 billion tons. According to our measurements, it's losing more mass than it has. The math doesn't add up. What would you do if you were the first person to see this? Let me take you back to July 2025. The Hubble Space Telescope captured something strange. A small glowing cloud. Nothing dramatic, nothing unusual. Just another interstellar visitor passing through our cosmic neighborhood. Scientists cataloged it, named it 3I/ATLAS. The third confirmed interstellar object ever detected. They expected it to behave like a comet. They were wrong. Fast forward 4 months, November 8th and 9th, 2025. New telescopes lock onto 3I/ATLAS, and what they see defies explanation. The small glowing cloud Hubble observed, it's gone. In its place, massive collimated jets of material exploding outward. One jet stretching 1 million kilometers toward the Sunday, another jet blasting 3 million kilometers away from the Sunday. To put that in perspective, if you could drive a car at highway speed, it would take you over 300 years to travel the length of that tail. This isn't just bigger than what Hubble saw. It's 3,000 times larger. Something happened between July and November. Something violent, something unprecedented, and scientists are still debating what triggered it. Think about that for a moment. An object from beyond our solar system, from the space between stars, suddenly erupts with enough energy to shoot material millions of kilometers into the void. And we have no idea why. Comment what you think is happening, even one word. Here's where it gets stranger. Every comet we've ever studied follows one simple rule. The solar wind pushes their tail away from the Sunday. Always. The sun emits a constant stream of charged particles. The solar wind that flows outward through the solar system at over 1 million kilometers per hour. When a comet approaches the sun, this wind blows its gas and dust into a tail that always points away from our star. It's basic physics. It's never been violated. Until now. 3I/ATLAS has jets pointing both toward and away from the Sunday. Simultaneously, the jet pointing toward the sun is actively pushing against the solar wind. Imagine standing in a hurricane and watching smoke from a cigarette drift toward the storm. That's what we're seeing. The object is generating enough force to counteract one of the most powerful flows of energy in our solar system. How? Avi Loeb, Harvard astrophysicist and one of the leading voices in interstellar object research, ran the calculations. What he found was impossible. Based on the size and brightness of the jets, 3I/ATLAS is losing approximately 50 billion tons of material every month. 50 billion tons! To visualize that, imagine the entire mass of Mount Everest being vaporized 30 times over every single month. But here's the problem. Based on its size, roughly 1.6 kilometers wide, the entire object has an estimated mass of only 33 billion tons. Read that again. It's losing 50 billion tons per month, but it only weighs 33 billion tons total. According to standard comet models, the object is losing more mass than it physically possesses. Loeb's exact words, "The math is not mathing." This doesn't match what we've observed in any previous comet. According to our current understanding of mass conservation, you cannot lose more than you have. Yet 3I Atlas appears to be doing exactly that. One hypothesis: our measurements are incomplete. A equals natural phenomenon, B equals something unknown, C equals we need new physics. Comment A, B, or C, no wrong answers. Scientists proposed a solution: fragmentation. Maybe 3I Atlas didn't arrive as one solid object. Maybe it broke apart. We've seen this before. In 1992, Comet Shoemaker-Levy 9 fragmented into 21 pieces before slamming into Jupiter. In 2007, Comet Holmes suddenly exploded, becoming the largest object in our solar system for a brief period bigger than the Sun in apparent size. Fragmentation explains the mass loss paradox. If the object broke into multiple pieces, each piece contributes its own jet. More surface area exposed to solar heating. More outgassing. More mass loss. The combined mass of all fragments could easily exceed 33 billion tons. Problem solved, right? Except we have no confirmation of fragmentation. No telescope has resolved 3I Atlas into multiple distinct objects. The jets appear to originate from a single source. If fragmentation occurred, when did it happen? Why didn't we see it? Hubble observed 3I Atlas in July as a compact, glowing cloud, no signs of breakup. 4 months later, these massive jets appear. Did it fragment in the intervening months? Possible. But fragmentations this dramatic are usually accompanied by sudden brightening and outbursts astronomers can detect across the solar system. Nobody reported an outburst, so either the fragmentation was unusually subtle, defying historical patterns, or something else is happening, something we've never seen before. Now layer in another mystery. 3I Atlas moves on a retrograde orbit. It's traveling in the opposite direction to the planets. All 8 planets in our solar system orbit the Sun counterclockwise when viewed from above the North Pole. 3I Atlas orbits clockwise. That alone isn't unprecedented. Some comets and asteroids have retrograde orbits. But here's the kicker. Its orbit lies almost exactly on the ecliptic plane. The ecliptic is the flat disk where all the planets orbit. Most interstellar objects enter our solar system at random angles coming from above or below the ecliptic. The probability of an interstellar object arriving on a retrograde orbit that also lies precisely on the ecliptic plane, 0.2%. 1 in 500. Not impossible, but highly improbable. Does this change how you see our place in the universe? Let's talk about what makes 3I Atlas truly unprecedented. Every comet, every single one ever observed, follows predictable thermodynamic patterns. As a comet approaches the Sun, solar radiation heats its surface. Ice sublimates into gas. The gas escapes, carrying dust particles with it. This creates the coma, the fuzzy atmosphere around the nucleus, and eventually the tail. The rate of mass loss correlates directly with solar heating. Closer to the Sun equals more heating equals more outgassing. It's a direct relationship. Scientists can predict comet behavior with remarkable accuracy. Until 3I Atlas, the object's mass loss rate exceeds what solar heating alone can explain by current models. Even accounting for fragmentation, even assuming multiple fragments, the energy budget required to eject 50 billion tons of material per month from an ice and rock object this far from the sun doesn't match known comet behavior. According to standard thermodynamic calculations, there's not enough heat input. Something else is providing energy. But what? Then there's the structure of the jets themselves. Collimated jets, tightly focused streams of material shooting in opposite directions. This requires a mechanism to channel the outgassing into specific directions. On comets, jets form when gas escapes through vents or fissures in the nucleus. But the jets we're seeing from 3I Atlas are massive, millions of kilometers long. Maintaining collimation over such distances requires extraordinary precision. Think about trying to shoot a beam of water from a hose and keeping it perfectly straight for 3 million kilometers. The diffusion alone would scatter it within thousands of kilometers. Yet these jets remain distinct and focused. What kind of internal structure could maintain that? Here's where things get philosophical. When Oumuamua, the first confirmed interstellar object, passed through our solar system in 2017, it exhibited non-gravitational acceleration. It sped up in a way that gravity alone couldn't explain. Scientists propose outgassing as the explanation, jets of material acting like tiny rocket thrusters pushing Oumuamua faster. But Oumuamua showed no visible coma or tail, no outgassing signatures, just acceleration. The debate continues to this day. Now we have 3I Atlas, visible jets, clear outgassing, but mass loss that exceeds physical possibility. Are these objects connected? Are we seeing different manifestations of the same phenomenon? Or are we dealing with two separate mysteries that happen to both come from interstellar space? Write one sentence. This means one more detail that haunts researchers. When astronomers analyze light from comets, they can identify specific molecules: water vapor, carbon monoxide, cyanide compounds. Each molecule absorbs and emits light at characteristic wavelengths. It's like a chemical fingerprint. But 3I Atlas? The spectral data is incomplete. Some observations show signs of typical comet chemistry. Others show anomalies, unexpected emission lines, or the absence of expected ones. It's as if the object's composition is inconsistent, like it's changing. Or like we're observing multiple objects with different chemistries pretending to be one. Fragmentation could explain this. But so could something else. Something we don't have a name for yet. Step back for a moment. Forget the numbers. Forget the physics. Think about what 3I Atlas represents. This object has been traveling through the space between stars for millions, possibly billions of years. It formed around another sun in another solar system, orbiting a star we may never identify. At some point, gravitational interactions ejected it, sent it tumbling into the cosmic void. For eons, it drifted through absolute darkness, temperatures barely above absolute zero, no light, no warmth, just a faint whisper of radiation left over from the Big Bang. And then, by pure chance, it crossed paths with our solar system. Our sun, a medium-sized yellow star in an unremarkable spiral arm of an average galaxy. 3I Atlas fell toward our Sunday. And as it did, something woke up. The ice that had been frozen for billions of years began to sublime. The jets began to fire, and we were here to see it. There are 400 billion stars in the Milky Way galaxy. Each star potentially hosts planets. Each planetary system potentially ejects objects like 3I Atlas. Right now, at this very moment, there are trillions, maybe quadrillions of interstellar objects drifting through the space between stars. Silent, invisible, waiting. We've confirmed only 3, Oumuamua, Borisov, and now 3I Atlas. 3 objects out of quadrillions. What are the odds that the first 3 we detect all show unusual behavior? Oumuamua, non-gravitational acceleration. Borisov, normal, but that makes it the outlier. 3I Atlas, mass loss paradox. Is it selection bias? Do we only notice the weird ones because they're bright, active, or anomalous? Or is the universe trying to tell us something? Maybe the vast majority of interstellar objects are strange. Maybe Borisov is the exception. Maybe everything we think we know about comets only applies to objects born in our solar system. And when objects come from outside, forged in alien environments around distant stars, they play by different rules. Here's what keeps me up at night. We are one species on one planet orbiting one star in one galaxy. Our entire understanding of physics, every law, every equation, every theory is based on observations made within a tiny bubble. Our solar system is 92 billion miles wide. The Milky Way galaxy is 600,000 trillion miles wide. The observable universe is 540 sextillion miles wide. We've physically explored 0.0000001% of the universe. And we're confident we understand how it works. 3I Atlas might be showing us that we don't, that our physics is local, that the rules change when you venture into the true depths of space. Or maybe, and this is the question that keeps coming up in scientific circles, could something like this be natural at all? Some will wonder whether it's natural or engineered. I'm not claiming either answer. I'm saying we don't have enough data yet. And the not knowing is the most human thing about this entire story. Because we're a species that needs answers. We build telescopes. We write equations. We launch spacecraft. All because we cannot tolerate mystery. We have to know. And 3I Atlas is daring us to find out. Scientists are analyzing whether this object fits current comet models or represents something we don't yet understand. Write one sentence. This means, right now, observatories around the world are tracking 3I Atlas. The James Webb Space Telescope may soon turn its infrared eyes toward the object. Webb can detect heat signatures invisible to optical telescopes. If 3I Atlas is fragmenting, Webb might resolve individual pieces. If there's an internal heat source, something generating energy beyond solar radiation, Webb could detect it. We'll know more in the coming weeks. The European Southern Observatory is coordinating spectroscopic observations. They're trying to decode the chemical composition. Is this water ice, like most comets, or something else? Methane? Nitrogen? Exotic ices that only form in the coldest regions of space? NASA's Asteroid Terrestrial Impact Last Alert System, ATLAS, will continue monitoring the object's trajectory, any changes in brightness, any new outbursts, any fragmentation events. They'll catch it. But here's the reality. 3I Atlas is moving away from us now. It's already beyond Mars's orbit, heading back toward the outer solar system. In a few years, it will be too faint to observe, and then it will leave. Back into interstellar space, back into the dark, and we may never see it again. So what don't we know? Did 3I Atlas fragment? If so, when and why? What's causing the mass loss paradox? Is our math wrong? Or is something else happening? Why is the orbit so precisely aligned with the ecliptic? Are the jets stable, or will they change as the object moves farther from the sun? What's the composition? Is this a typical comet or something fundamentally different? And the biggest question, is this connected to Oumuamua, two anomalous interstellar objects in 8 years? Coincidence or pattern? We don't know, but we're watching. You know what I think? I think 3 I-Atlas is a reminder that the universe is not tame. It's not predictable. It doesn't care about our equations or our theories. For centuries, we've looked up at the stars and seen order. Planets orbiting in ellipses. Galaxies rotating according to gravitational laws. Light traveling at a constant speed. We've convinced ourselves that the universe is knowable. That given enough time, enough data, enough processing power, we can understand everything. And then something like 3 I-Atlas comes along. An object from beyond our solar system. An object that doesn't match our current comet models. And it whispers, you don't know as much as you think you do. Maybe that's terrifying. Or maybe it's exhilarating. Because if we don't know everything, that means there's still discovery ahead. Still mystery, still wonder. We're not at the end of science. We're barely at the beginning. And 3 I-Atlas, this strange, impossible, beautiful object from the space between stars, is proof. Maybe the universe isn't silent. Maybe we just never listened. Maybe objects like 3 I-Atlas and Oumuamua have been passing through our solar system for billions of years. Dozens of them, hundreds of them. And we never noticed because we weren't looking. Or we didn't have the technology. Or we weren't ready. But now we are. Now we have telescopes that can spot a mile-wide object billions of miles away. Now we have computers that can calculate mass loss rates in real time. Now we have the audacity to ask, what are you? And 3 I-Atlas answers with jets of material stretching millions of kilometers. It answers with mass loss that defies physics. It answers with a retrograde orbit aligned against all probability. It doesn't give us clarity. It gives us more questions. And maybe that's the point. Maybe the universe wants us to stay curious. Maybe every answer is just an invitation to ask deeper. Maybe 3 I-Atlas isn't an anomaly. Maybe it's a message. So tell me, what do you think happens next?